we're going to actually calculate work in joules. And it says, find the amount of work in joules done on the surroundings when 4.18 liters of an ideal gas, initially at a pressure of 6.55 atmospheres, is allowed to expand at constant temperature to 10.18 liters by reducing the external pressure to 2.69 atmospheres. So the equation for this is that work equals minus P delta V, where P is the external pressure. So we could also write P or final, or anyway, delta V, where this is the external pressure applied as the gas expands. And the final part, the P sub F, means that since there are two pressures in here, it's always going to be the last one. So by reducing the external, it's like, sure, initially it's at 6.55 atmospheres, but this calculation always takes the final pressure to do it. Now, let's see. We start at 4.18 liters. We end at 10.18 liters. So 10.18 liters will be our final volume. V sub F, or V sub final. Our initial volume will be 4.18 liters. And filling this in now, we've got 2.69 atmospheres. And our delta V is always V final minus V initial. And again, volume is a state function, meaning that it doesn't matter how we go from our initial to our final volume, the change will always be the same. It is path independent. V final, 10.18 liters. V initial, 4.18 liters. And multiplying this out, uh, 2.69, I'm going to do this one first. 10.18 minus 4.18, I get 6 times 2.69, and I'll just put in the minus sign there. Minus 16.1 to 3 sig figs. My units on this are liter atmospheres, like so. There is a conversion factor for converting liter atmospheres to joules. I hope it's on the sheet here. There it is. 1 liter atmosphere equals 101.325 joules. That's going to allow us to create a unit conversion factor to convert our liter atmospheres into joules. And that's a point there. That's 101.325. Want to make sure you knew it was not a comma. I'm going to leave out my minus sign, which I oftentimes do, and I hope to put it back in at the end. Times 101.325. I get negative 1631 joules. And the negative means that the system did work on the surroundings. And just to bring this home a little bit, so if we had a gas that was confined in a space here, and if the gas expands, to a larger volume, then it has pushed the atmosphere back, or has pushed the gas here back. What's the best way to say this? That's a rhetorical question. Let me figure it out. Pushed the surroundings back. Which is how it does work on the surroundings. You can think of pushing a rock up a hill as doing work. Here, if you push against something, you are doing work. What we might think is, well, we haven't gotten there yet, but if we have gases in here, in a piston in a car, and there's a reaction in here that causes the gas to expand to a larger volume, this piston could be attached to a rotor or part of an engine, and this is where my knowledge stops, by the way, and probably your knowledge picks up, that turns part of a piston in an engine, or this is a piston in an engine, and it turns part of the other part of the engine, and it does work to make the car move. And that's really the engineering application of this. We just haven't talked about the reactions that generate the gases yet. But if you push the surroundings back, you did work on the surroundings.
Hey, Professor. I did the same problem as you, fairly similar, and I got a similar answer. It was negative 1496.8 joules.
Yes.
When I entered that answer in, it told me that it's wrong and that the right answer was 680.66082.
Selden, so let me check on that then. And
I can walk you through what I wrote down because I was following through and kind of using the same numbers that you were using if you want, but it looks similar to what you have
down. Yeah, so I mean, I think the key thing to this is make sure you use the final pressure.
I did, yeah.
Yeah, then let me, Selden, let me check on that.
Okay.
This may be, so then what I'll do is I'll either email you if I found out that the problem is actually right and how to fix yours.
That's fine. I can also try it again and see if I get another wrong answer or right answer. It doesn't bother me doing that.
Yeah, no, it sounds like you have the right approach, especially if what you just watched sounds right. But let me see. So make sure that I did the liter atmospheres to joules conversion myself. I'll double check that.
Okay.
Yes, but thanks for letting me know, and I will get back to you.
Sounds good.